If you're watching this because you work under a weatherization or home performance program, there's a good chance you're used to doing ventilation calculations using ASHRAE Standard 62.2. For many years, this was the method required by the Weatherization Assistance Program and referenced by BPI standards. New construction programs like Energy Star Homes and Lead for Homes specified ASHRAE 62.2, 2007, or the 2010 version. ASHRAE 62.2 2013 gives very different results from these older standards. It'll be helpful to understand the differences. Just to give you a sense of what will change if you transition from standard 62-89 to 62.2, let's consider the results of a study done by the Wisconsin Energy Center in 2006. The Wisconsin Weatherization Assistance Program was transitioning from ASHRAE 62.89 to the 2004 version of 62.2 in late 2005. The study found that only 34% of homes required a ventilation system using 62.89, but when 62.2 was implemented, it went up to 60%. This is not a trivial result. The average cost of an installed system, including the fan, controls, ducting, and installation labor, was $646. That's a big cost addition to a substantial number of jobs. And remember, this is for ASHRAE 62.2 2004. The 2013 version is significantly more restrictive than the 2004 version. To show you the differences in the results, we'll run the calculations on our sample existing home using the formulas in ASHRAE 62.2 2013, 62.2 2007, and 62.89. Remember, our house was an existing 1960s vintage, 1,200 square foot ranch in central New Jersey with 3 bedrooms, 5 occupants, and a blower door reading of 2,000 CFM at 50 pascals. We did the ASHRAE 62.2 2013 calculations in the last lesson. You can go back and review them if you want to. The base formula gave us a requirement of 74 CFM. The local ventilation deficit from the kitchen and bathroom was 5 CFM, and the infiltration credit, based on the blower door reading, was 50 CFM. When we combine them all, we come up with 74 plus 5 minus 50, which equals 29 CFM. A fan is required and it must provide 29 CFM of continuous ventilation. The 2004 and 2007 versions of ASHRAE 62.2 used a different equation. You may notice that the floor area is multiplied by 0.01 instead of 0.03. The difference is that those standards included a built-in infiltration credit of 2 CFM per 100 square feet of floor area. There's an additional infiltration credit allowed if the leakage is determined with a blower door test to be higher than that standard credit. These versions didn't include any adjustment for shortcomings in local exhaust. For our example house, the total desired ventilation rate is 50 CFM versus the 74 CFM calculated with the 2013 version. Now let's take a look at the infiltration credit. The infiltration credit in these standards is fairly complicated. Take a look at the equation. You can state it in words the way the standard does. When infiltration has been measured in excess of the standard credit of 2 CFM per 100 square feet, the required ventilation rate can be reduced by half of the excess. That's what the equation does. It looks at the infiltration rate estimated from the blower door test and subtracts the standard credit of 2 CFM for every 100 square feet of floor area. That gives us the excess infiltration. Then it multiplies the excess by 0.5. We can only claim half of the excess as a credit. The next logical question is, how do we estimate the natural infiltration from the blower door test result? Well, these earlier versions of ASHRAE 62.2 don't include an equation. They reference ASHRAE Standard 136 for the calculations, which is just about as convoluted as the ASTM standard referenced by 62.2 2013. But again, the industry adopted a simplified calculation that looks the same as the one used for the 2013 version. The natural infiltration is 0.052 times the weather factor times the height factor times the blower door result in CFM at 50 pascals. But there's a big difference. The W weather factor and the S height factor come from ASHRAE 136, and they're different than those listed in the 2013 version of ASHRAE 62.2, and they result in a higher infiltration estimate than those in the new standard. ASHRAE 136 lists only one New Jersey weather station in Lakehurst. That's close to Hamilton, so we'll use that W factor, which is 0.7. The S factor is again 1 because this is a single-story house. Now we can plug those numbers into the equation with our blower door reading. The estimated natural infiltration is 0.052 times the W factor of 0.7 times the S factor of 1 times the blower door reading of 2000 CFM. That gives us an estimated infiltration rate of 73 CFM. The 2013 version only estimated infiltration at 50 CFM. Now we need to plug everything into the formula for the credit. The natural infiltration, CFM-INF, is estimated as 73 CFM. The floor area is 1,200 square feet, and we use that to calculate the standard credit. At 2 CFM per 100 square feet, the standard credit is then 24 CFM. That means we have an infiltration excess of 73 minus 24, or 49 CFM. We can claim half of that. Our credit is therefore 24.5 CFM, which I rounded down to 24. We can now plug that back into the original equation. The required fan size is the total desired ventilation rate from the base equation minus the infiltration credit. We calculated a desired ventilation rate of 50 CFM, and our infiltration credit is 24 CFM. The difference is 26 CFM. So these earlier versions also required a fan, but with a size of 26 CFM versus 29 CFM for the 2013 version. The final result is not too different, but the calculations sure are. Now let's look at the method typically used that aligns with ASHRAE Standard 62.89. In this case, we look at the house size and number of occupants separately. We want either 0.35 air changes per hour or 15 CFM per occupant, whichever is higher. First, we'll evaluate based on house size. To calculate a ventilation rate based on that, we need the house volume rather than the floor area. Since it's a single-story house, we can simply multiply the floor area by the 8-foot ceiling height. That gives us a volume of 9,600 cubic feet. If we multiply that by 0.35 air changes per hour and divide by 60, we get the desired flow rate in CFM. It's 56 CFM. Next, we'll evaluate based on the number of occupants. There are 5 occupants and 3 bedrooms, so we'll use the actual occupancy since it's higher than bedrooms plus 1. If we multiply 15 CFM times the 5 occupants, we get a total of 75 CFM. That's actually not very different from the 74 CFM rate calculated with ASHRAE 62.2 2013. In any case, we take the larger of these two numbers, so our desired ventilation rate is 75 CFM. Now we want to compare the desired ventilation rate to the natural infiltration rate. This is where the old method is very different. It uses a simpler equation. The natural infiltration rate is estimated as the blower door result divided by an N factor developed by the federal Lawrence Berkeley labs. This N factor is based primarily on the geographic location of the house and the number of stories. Here's a table of N factors used by the New Jersey Home Performance with Energy Star program. For a single-story house, the N factor is 18.5. If we divide the blower door reading of 2000 by the N factor of 18.5, we get an estimated natural infiltration rate of 108 CFM. That's a lot higher than the rates of 73 and 50 CFM estimated by the 2007 and 2013 standards. Finally, we can compare the estimated infiltration of 108 CFM to the desired ventilation of 75 CFM. From this, we conclude that natural infiltration is adequate and no mechanical ventilation is needed. Now let's summarize the comparison we just did. The 1989, 2007, and 2013 ASHRAE standards use different formulas to calculate the desired ventilation rate. Both the 1989 and 2013 versions calculate high desired rates. The 2007 version calculates a low rate because it has a built-in infiltration credit. The 2013 version adds additional ventilation if the local exhaust is deficient, making the total requirement even higher. The three standards use different methods for calculating an infiltration credit. The 1989 version uses an N factor and calculates the highest credit. The 2007 version calculates a moderate level of estimated infiltration, but the net credit is low because it subtracts out the credit built into the base formula. And the 2013 version calculated a low estimated infiltration. You can see that as time has progressed, we're attributing a lower natural infiltration rate to a given blower door reading. Is this based on sound building science? Are we using similar assumptions when we do energy savings estimates? Those are good questions, and I'll leave it up to you to do more research if you're curious. The net result of all of this is that the 1989 version of ASHRAE 62 usually did not require mechanical ventilation. The 2007 version frequently requires it, and the 2013 version requires it in the majority of houses.